Have you ever wondered why a moving truck is harder to stop than a bicycle going at the same speed? Or why a bullet, despite its small size, can cause such significant damage? The answers to these questions lie in the fascinating concept of linear momentum. Linear momentum, a fundamental concept in physics, is essentially the quantity of motion an object has. It's calculated as the product of an object's mass and its velocity. So, a heavier object moving at a high speed will have more momentum than a lighter one moving at the same speed. This explains why it's harder to stop a moving truck than a bicycle. The truck, being heavier, has more momentum. But what about our other question? Why can a bullet so small and light cause such significant damage? This is because even though the bullet is light, it moves at an incredibly high speed and thus its momentum is high. This is why a bullet can penetrate surfaces and cause damage. So, we can say that momentum is not just about how heavy an object is, but also how fast it's moving. It's a vector quantity, meaning it has both magnitude and direction. The direction of the momentum is the same as the direction of the object's velocity. But what happens when two objects collide? Well, this is where the principle of conservation of momentum comes in. The total momentum of a system of objects is always conserved unless an external force is applied. This means that the combined momentum of the objects before the collision equals the combined momentum after the collision. What's fascinating about momentum is that it's not only applicable to large objects like trucks and bullets, but also to the microscopic world of atoms and particles. In quantum mechanics, the Heisenberg uncertainty principle states that we cannot precisely know both the position and momentum of a particle at the same time. The more precisely we know one, the less precisely we can know the other. So, to recap, linear momentum is the product of an object's mass and velocity. It's a vector quantity, having both magnitude and direction. The principle of conservation of momentum states that the total momentum of a system is always conserved unless acted upon by an external force. And in the realm of quantum mechanics, momentum plays a crucial role in the Heisenberg uncertainty principle. Understanding linear momentum and its principles not only helps us make sense of the world around us, but also forms the foundation for many branches of physics. Whether it's explaining why a truck is harder to stop than a bicycle, or understanding the behavior of particles in quantum mechanics, the concept of momentum plays a key role. So the next time you see a moving object, remember, there's more to its motion than meets the eye.